let's try to solve another Leetcode problem. 1973, count nodes equal to sum of descendants. Let's first try to understand it. So we're going to use the first example. So for this, the root node 10, so the sum of its descendants is going to be 3, 4, 2, 1. So this is one of the possible results. And now we're going to check the node 3. So for node 3, we have 2 plus 1, it's going to equal to 3. And for this node 4, we don't have any descendants. And also for node 2 and 1, we don't have any descendants. So the total number of them going to be 2 to meet the conditions. Yeah. So we just need to return the number of nodes where the value of nodes is equal to the sum of the values of its descendants. Yeah, I think it's really easy to understand. And definitely this is a really good problem because the descriptions is easy to understand and the problem itself is not so hard. Yeah, so how can we solve it? And definitely we don't need to use brute force. So we can actually we can solve it by the post-order traversal. So let's check the number of nodes. It's going to be 10 to the power 5. It means we cannot solve it by using the brute force. So the post-order traversal is that before we are calculating the root node 10, we already know what is the total sum for the left subtree. It's going to be 6, 3 plus 2 plus 1. And for the right subtree, it's going to be 4. So it means we're going to count it as 1. So before we are checking this node 3, we already know the values for the left subtree, it is 2, and the right subtree, it is 1. So 2 plus 1 equal to 3, so we're going to have another count. So the total number of them going to be 2. Yeah. Now let's just write a post-order traversal. So I'm going to define a DFS, and starting from the node, so if not node, yeah, this means there's no node, this is a leaf node. So if this is a leaf node, I'm going to check the left child and the right child. So for the left child and right child, it's going to be a none. So I'm going to return a 0. So otherwise, I'm going to check the left and the right, and definitely it's going to be equal to DFS not dot left. So the meaning of the DFS is is the total sum of the tree. So for example, DFS with node 10, the total sum gonna be the sum up of all those values. So DFS with node 3, so it's gonna be 2 plus 1 plus 3, it's gonna be 6. Yeah, so we should understand the meaning of DFS. It is the total sum of all values of this subtree. And similarly, we can use the DFS not dot right. Yeah. Now, our final return is going to be L plus R plus not dot value. But we need to prepare a variable to record the final result. Yeah. So the condition is if L plus R equal to not dot value. Yeah. So this means if 2 plus 1 equal to 3, we're going to count it as 1. If 6 plus 4, because 3 plus 2 plus 1 is going to be 6. 6 plus 4 equal to 10, we're going to count it as 1. So the self.result is going to plus equal to 1. Now let me just prepare self.result is going to be 0, and we're going to run the DFS with root node, and finally we're going to return self.result. Now let me just run it and submit it to check. So as you can see, it works, and I think the speed is okay because the time complexity is ON, because this is just post-order traversal. And I think that's all for it. Thank you for watching. See you next time.